Lecture 25, Language and Thought. Once we've engaged in some cognitive activity, perceived an object or remembered an event, induced a concept or deduced category membership, rendered a judgment, made an inference, or solved a problem, then we may use our capacity for language to communicate what we've experienced, thought, or done to someone else. But language isn't just a tool for communication. It's also a powerful tool for thinking. We use words to symbolically represent the objects and events we encounter in our environment and to represent concepts and categories. We also use language to manipulate these mental representations in the course of reasoning and problem solving. The ability to communicate is not unique to humans. Many non-human animal species have the ability to communicate with other members of the same species. For example, animals may exchange signals during the mating process. Think of the male stickleback's zigzag dance, or the female stickleback's head-up receptive posture. They communicate threats about intruders on their territory, as in the head-down threat posture of the male stickleback. Or they may signal alarm at the sight of a predator. Foraging honeybees perform a kind of waggle dance that indicates the position of food relative to the sun and its distance from the hive. These are all social displays, instinct-like, innate, expressive movements. They don't have to be learned, and they're performed in narrowly defined situations. Other species have more complicated communication systems that seem to be acquired through a form of learning. The classic case here is birdsong. Typically, male birds sing, but female birds do not, and each species has a characteristic song which it uses to identify potential mates. And within each species, there are also territorial dialects, variations on the basic song that seem to help preserve the gene pool in a particular area. Studies of sparrows indicate that birdsong seem to be learned through exposure to other males, but this isn't the usual form of learning. In the natural setting, all young males acquire the dialect sung by their parents. However, sparrows cannot learn the songs of other species. There appears to be a kind of critical period for learning, similar to that seen in imprinting in ducks and geese. If a young sparrow is exposed to its song before it's at a particular age, or after it's reached a particular age, it'll sing only a crude approximation of its song. And interestingly, for a form of learning, practicing isn't important. After exposure, the young male sparrow will remain silent for several months, and then it will sing its song perfectly the very first time. Apparently, the bird inherits, as part of its innate biological endowment, a crude template of its species' song. This template is then refined through experience, through exposure to whatever particular dialect of the song is sung by its parents. This counts as an instance of learning. It's a relatively permanent change in behavior that occurs as a result of experience. But notice that this learning does not occur through reinforcement. There's no practice, and there's no regime of rewards and punishments. Birdsong shows some interesting parallels to human speech. Every normal child learns to speak his or her native language. This learning occurs naturally without reinforcement. Even if the child is raised in an extremely impoverished linguistic environment, as long as the child is exposed to some language, it will pick up that language. There's also a critical period for language development. If children are linguistically isolated until puberty, they show very poor language skills thereafter. And if children learn a second language before puberty, they speak that second language without an accent. But if they learn the second language after puberty, that language is spoken with an accent. When all is said and done, though, human language is different from any other form of communication that we know of in the animal kingdom. Human language is differentiated from these other communication systems by 5 important properties. The first of these is meaning, by which we simply mean that language expresses ideas. The second property is reference. language refers to the real or imagined world of objects and events. The third is that language is interpersonal. Language is used to communicate one person's ideas to someone else, to change their opinions perhaps, or to accomplish some other goal. Language is also highly structured. Linguistic utterances are organized according to the rules of grammar. Prescriptive grammar is a set of authoritative rules for speaking meaningful utterances. It's a prescription for how language ought to be spoken. Descriptive grammar is a set of descriptions of natural speech, how language is actually used. The rules in grammar are finite in number, but they permit the generation of a virtually infinite number of different meaningful sentences. Which brings us to the last distinctive property of human language, which is creativity. People can generate and understand novel utterances, utterances that have never been heard before or spoken by them or anyone else ever before. For example, it's been estimated that there are some 1 nonillion meaningful 20-word sentences that can be composed in English. That's 10 to the 30th power, 1 followed by a string of 30 zeros. Each of us can understand each of these sentences effortlessly, provided that we know what the words mean. But there are only 3 billion seconds in a century. There's simply not enough time for us to have learned the meaning of each of these sentences by exposure, even at the rate of 1 sentence per second for an entire lifetime. These properties combine to make human language unique in nature. Social displays are stereotyped and obligatory. Birds are known to improvise on their songs, but the basic song remains unchanged. Human speech, by stark contrast, is optional, and it is creative. Now, it's true that some non-human primates have been taught to perform some linguistic tasks, despite the fact that they lack the proper vocal apparatus for anything resembling human speech. Washoe and Nimchimpsky, 2 chimpanzees, and Coco, a gorilla, learned some aspects of American Sign Language. Another chimpanzee, Sarah, learned to string tokens together in order to form elementary sentences. However, the training of these animals was very arduous, required lots of time, lots of effort, lots of reinforcement, and it's not clear that any of it actually reflects language. Nimchimpsky, for example, rarely signed more than a 2-word sentence. And the average length of Nim's utterances showed no development over time. Sarah was able to learn symbols to refer to objects, but she never really was able to string them together to form sentences, the way humans form sentences. No primate, even under ideal conditions, has shown the language ability that a normal 2-year-old human child acquires effortlessly under the most impoverished conditions. The general consensus is that chimpanzees can acquire some aspects of language semantics, learning the meanings of symbolic words or symbolic gestures, but they have little or no capacity for linguistic syntax, the ability to string words together into meaningful utterances. Human language is indeed an ability that is unique in nature. When you consider that chimpanzees are our nearest evolutionary relative, and gorillas are not far behind, this discontinuity is really interesting and provocative. Language is organized hierarchically into a number of different levels of analysis. At the lowest level, the phoneme is the smallest sound unit of speech. Each language has its own set of phonemes. In English, there are about 40. The human infant speech apparatus can produce all the phonemes in all known natural languages. This is what comes out when babies babble. However, during their babbling period, infants gradually narrow their repertoire of phonemes to those of their native language, that is, the language to which each infant is exposed. This results in an accent when the person learns to speak a new language as an older child or as an adult. At the next level, the morpheme is the smallest unit of speech that carries meaning. In English, there are about 50,000 of these, roots, stems, prefixes, and suffixes. There are, further, two classes of morphemes. So-called open class morphemes consist of nouns, verbs, adjectives, and adverbs. They're called open class morphemes because new members can be added to the class just by inventing new words like radar or snarf. Closed class morphemes consist of articles, connectives, prepositions, prefixes, and suffixes. They're words like a, and, but, and be. Phonemes are combined into morphemes by phonological rules, which specify which combinations of speech sounds are legal in a particular language. At the next level, the word consists of one or more morphemes, a root or a stem, plus perhaps a prefix or a suffix, or both. In English, there are about 200,000 of these. Morphemes are combined into words according to the same kinds of phonological rules. At the next level, phrases and sentences consists of strings of one or more words that contain some meaningful proposition. In English, or for that matter any other language, the number of possible phrases and sentences is essentially infinite. Remember the 1 nonillion estimate from a couple of slides ago. Then again, there are two classes of sentences. Language basics are simple sentences that consist only of open class morphemes, such as "Mommy go store," the kind of utterance you'd hear from a very young child. Language elaborations are complex sentences that include closed class morphemes, such as "Mommy goes to the store," the kind of sentence that you'd expect to hear from an older child or adult. At each level of the hierarchy, the combination of lower-level elements is governed by rules to generate higher-level elements. Phonological and morphological rules combine a finite number of phonemes into an essentially infinite number of words. Grammatical rules govern how words can be strung together into an infinite number of propositions. These grammatical rules, known as syntax, make human language possible, allowing us to put new words together in new ways to express thoughts that have never been thought before. I talked a little bit about phonology when I discussed speech perception, so let's go right to the heart of the psychology of language, which is syntax. What we call the surface structure of language, the utterance as it's expressed by speaker and heard by the listener, is governed by what are known as phrase structure rules. Phrase structure grammar is represented by rewrite rules of the following form. A noun can be rewritten as man, woman, horse, dog, or whatever. Verb can be rewritten as saw, heard, hit, and so forth. Article can be rewritten as a, and the. That's a closed class morpheme. Adjective can be rewritten as happy, sad, fat, timid, and so on. A noun phrase consists of an article plus an adjective plus a noun. A verb phrase can be rewritten as a verb plus a noun phrase. And a sentence can be rewritten as a noun phrase plus a verb phrase. So a simple declarative sentence takes the form of the first noun phrase verbed the second noun phrase. And it turns out that these few rewrite rules, applied just to the 13 words shown on this slide, can generate almost 5,000 different sentences, all with the form the first noun phrase verbed the second noun phrase. A fat man saw the timid dog. Here's how the surface structure of that sentence would be analyzed in terms of a phrase structure grammar. We've got a noun phrase, a fat man, and a verb phrase consisting of a verb, saw, and another noun phrase, the timid dog. A fat man saw the timid dog. Now remember, there are roughly 200,000 words in English, and more words are being invented every day. So you can see what we mean when we say that an infinite number of sentences can be generated by applying a finite number of rules to a finite number of words. The grammatical rules of phrase structure look a lot like the rules you probably learned in 7th grade English, but they also have a psychological reality. Consider the famous nonsense poem, Jabberwocky, by Lewis Carroll from his Alice books. "'Twas brillig, and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the momraths outgrabe. Beware the Jabberwock, my son, the jaws that bite, the claws that catch. Beware the Jubjub bird, and shun the frumious Bandersnatch. He took his vorpal sword in hand, long time the manxome foe he sought. So rested he by the tum-tum tree, and stood a while in thought. And as in uffish thought he stood, the Jabberwock, with eyes of flame, came whiffing through the Tolgi wood, and burbled as it came. 1, 2, 1, 2, and through, the vorpal blade went snicker-snack. He left it dead, and with its head he went galumphing back. And hast thou slain the Jabberwock? Come to my arms, my beamish boy. O frabjous day, Callooh, Callay, he chortled in his joy. 'Twas brillig, and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the momraths outgrabe. Now, we don't know what this poem means exactly. It's a nonsense poem, because so many of the words in it are nonsense. But we do know something of the meaning, simply because the structure of the poem follows the rules of English grammar. For example, we know that the toves, whatever they are, were slithy, whatever that is, and that they were gyring and gimbling, whatever those actions are, in the wabe, whatever that is, that the borogroves were mimsy, and that the momraths were outgrabe. So the syntax is a clue to meaning, and to the extent that we understand this poem at all, or that we get Carroll's joke, we get it by virtue of having in our heads something like phrase structure grammar. And in fact, over the subsequent century or so, some of Lewis Carroll's neologisms, made-up words, actually made it into the English dictionary. Galumphing is my favorite, but there are others. The psychological reality of phrase structure grammar is also supported by experiments of various kinds. For example, William Epstein conducted an experiment in which he asked subjects to memorize strings of pseudo-words, like nonsense syllables. In the control condition, the subjects were simply presented with these letter strings and asked to commit them to memory. In the second condition, the strings were altered by adding prefixes and suffixes and things like that, so that they mapped more clearly onto phrase structure grammar. The strings look like the kind of sentences that Lewis Carroll might have written. It turned out that the syntactical strings were easier to learn than the control strings. Subjects required fewer trials to meet a criterion of learning, even though the syntactical strings contained more letters. The reason is that our knowledge of phrase structure grammar provides a framework, a schema, for organizing the strings into chunks resembling the parts of speech, and this syntactical organization supports better memory. Here is another experiment by Jerry Fodor and Thomas Bever, in which subjects were read sentences like, "That he was happy was evident from the way he smiled." There was a click, a noise, superimposed on the spoken sentence, and the subjects were asked to indicate where in the sentence the click occurred. Sometimes the click was located right at the boundary between a noun phrase and a verb phrase. In this case, at position 0, between the noun phrase, "that he was happy," and the verb phrase, "was evident." In other trials, the click was presented either within the noun phrase, say at position A, or within the verb phrase, say at position B. When the click was located right at the boundary between the noun phrase and the verb phrase, subjects generally located it accurately. But when the click was presented within the noun phrase or within the verb phrase, they made a lot of mistakes. And the vast majority of those mistakes entailed displacing the click toward the boundary between the noun phrase and the verb phrase. they hardly ever displaced the click away from that boundary. This suggests that the noun phrase and the verb phrases were perceived as separate units. Now, phrase structure is important, but it's not all there is to syntax, because there's a difference between the surface structure of a sentence and its deep structure. Consider, first, two sentences with similar surface structures that seem similar in meaning. John saw Sally and John heard Sally. However, similar surface structures don't guarantee similarity of meaning. Consider these two sentences. John is easy to please and John is eager to please. The differences in meaning can be demonstrated by rephrasing them in the passive voice. It is easy to please John means something quite different from it is eager to please John. So sentences with similar surface structures might have very different meanings. Similarly, sentences with quite different surface structures may have very similar meanings. Consider the sentence, John saw Sally, or Sally was seen by John, or it was John who saw Sally, or even it was Sally who was seen by John, wasn't it? These sentences all look very different, but they all mean pretty much the same thing. So you can have two sentences with very similar surface structures but very different meanings, and you can have two sentences with very different surface structures that have very similar meanings. That clearly indicates that something else is needed besides surface structure grammar or phrase structure grammar. This something else was identified by the linguist Noam Chomsky as transformational grammar, a set of rules that can generate many equivalent surface structures and can also uncover the kernel of meaning that's common to many different surface structures. This kernel of meaning is what Chomsky called the deep structure of the sentence. According to Chomsky, we get from deep structure to surface structure by means of transformational rules. And for that matter, we get from surface structure to deep structure by means of the same kinds of transformational rules. These rules can produce many equivalent surface structures from a single deep structure, and they can recover a single deep structure from many different surface structures. The deep structure of a sentence can be represented by its basic propositional meaning, representing the basic thought underlying the sentence. We can rewrite proposition as a noun phrase plus a verb phrase. And in Chomsky's view, the surface structure of a sentence consists of a proposition and an attitude towards that proposition. That attitude can be rewritten as assertion, or denial, or focus on the object, or whatever, so that a sentence consists of an attitude plus some proposition. Here in simplified form is how this system is supposed to work. Let's consider a proposition like, the boy hit the ball. That kernel of meaning can be expressed in many different ways. For example, we can simply assert that the boy hit the ball. Or we can take an attitude of denial. The boy did not hit the ball. Or we can take an attitude of questioning. Did the boy hit the ball? Or we can focus on the object. The ball was hit by the boy, rendering the proposition in passive tense. Or lots of different combinations like, the ball was not hit by the boy, was it? Which combines assertion, denial, question, and focus on the object. Chomsky argued that something like deep structure and transformational grammar is logically necessary in order to understand language. But we've long since learned in this course that we should start to worry when someone argues that something's logically necessary. As empirical scientists, we also need evidence of the psychological reality of deep structure and these kinds of transformational rules. As a first pass towards providing this evidence, consider some of the utterances of novices in a language, such as infants or immigrants who are just learning the language. These utterances tend to mimic the kind of deep structures that Chomsky hypothesizes. For example, I no go sleep, or why mommy hit Billy. Further evidence is provided by studies of memory for paraphrases. In such experiments, subjects study a sentence like, he sent a letter to Galileo, and then are asked to recognize studied sentences from a set of targets and lures. Interest in the experiment comes from recognition errors that are made in response to alternative phrasings of the test sentence. And it turns out that phrases that represent a different proposition but the same attitude are correctly rejected. Subjects who have seen a sentence like, "He sent a letter to Galileo," don't falsely recognize Galileo sent a letter about it to him. But phrasings that represent the same proposition, albeit with a different attitude, do tend to be falsely recognized. So subjects will falsely remember having studied the sentence, "A letter about it was sent to Galileo by him." This kind of evidence indicates that memory encodes the gist of the sentence, its kernel of meaning, rather than the details of its surface structure. And even more evidence is provided by a study of meaning verification. In these kinds of studies, subjects study a standard sentence like, "The boy hit the ball." Then they're presented with test sentences and asked to indicate which of the test sentences have the same meaning as the standard sentence. Sentences that involve only a single transformation are correctly identified very quickly, such as, "Has the boy hit the ball?" But sentences that involve two transformations, such as, "Was the ball hit by the boy?" take more time. This indicates that in understanding the sentence, the language processor has to somehow strip away the surface structure to unpack the deeper kernel of meaning beneath. What I just presented to you in very simplified form is the classic version of Chomsky's theory as it was presented in the late 1950s and early 1960s. And I want to note for the record that Chomsky's theory of syntax has changed radically since then in many respects. If you're really interested in language, you'll learn all about it if you take advanced courses in linguistics and psycholinguistics. I focus here on the standard theory because, first, that theory had an enormous influence on the development of psychology, and especially cognitive psychology. And also because the standard theory had enormous influence outside of psychology and linguistics, even in the arts and the humanities. Throughout all these developments, Chomsky has insisted that the human ability to acquire and understand any natural language is based on the fact that some grammatical knowledge is part of our innate biological equipment. Not that we're born knowing English or Chinese grammar, obviously. A child born of English-speaking parents but raised from birth in a Chinese-speaking household will speak fluent Chinese without even an English accent. For Chomsky, language acquisition occurs as effortlessly as it does because humans are born with a special brain module or system, he sometimes calls it a language acquisition device, that permits us to learn any language to which we're exposed. At the core of the language acquisition device is a body of linguistic knowledge that Chomsky calls universal grammar, a set of linguistic rules and principles that apply to all languages spoken by anyone, anywhere. Chomsky's theory implies that there is a module in the brain that is dedicated to comprehending and producing language. And, in fact, it was Chomsky's work that inspired Fodor's doctrine of modularity, a particular version of functional specialization in the brain that we talked about earlier in this course. For Chomsky, universal grammar and the language acquisition device come with us into the world as part of our basic mental equipment, just like we're born with lungs and hearts and eyes and ears. They're part of the biological stuff that makes us human and which separates us from other species such as chimpanzees, who, for all intents and purposes, lack the human capacity for language. Of course, different languages have different words, too. In English, we say man, where the Spanish say hombre. But Chomsky's not talking about words. He's talking about syntax, the fundamental structure of the grammatical knowledge that allows us to put words together into meaningful sentences. Chomsky's theory has changed a lot over the past half-century or so, and it's generated a lot of controversy. But in the end, it's been widely accepted, mostly on the grounds of plausibility. There has to be something like universal grammar and an innate language acquisition device to enable people to learn their native language as easily and as well as they do. For Chomsky, syntax is the key to human language. Human communication wouldn't be creative otherwise. But syntax isn't the only thing we need to understand utterances. Syntax provides structure, but it doesn't provide specific meaning. It only says that the first noun phrase verbed the second noun phrase. That's just the framework for a meaningful utterance. The frame has to be filled out with specific words and phrases. Semantics has to do with the specific meanings conveyed by the words in a proposition, what the various words refer to. And unless we know what the specific words refer to, we can't understand the meaning of what's being said to us. "'Twas brillig, and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the momraths outgrabe." We can get some sense of that from just the syntax, but we have no idea what brillig is and what toves are and in what respect they're slithy and what a borogrove is and what it means to be mimsy. The problem of reference has two general aspects, denotative and connotative. Denotative reference, or denotative meaning, concerns the object or event or attribute that a particular word labels. What does it mean to gyre? What are borogroves? And what does it mean to be mimsy? Connotative meaning has to do with the emotional meaning of a word, whether it's a good thing or a bad thing to be mimsy or brillig. This question of meaning or reference returns us to the problem of semantic as opposed to episodic memory, and how we can represent semantic memory in a network where nodes represent concepts and links represent the associative or propositional relationships among various concepts. And we've actually talked about meaning a lot when we talked about categorization, and how concepts are held together by prototypes or exemplars or whatever. Both semantic memory and categorization link language to thinking. But syntax and semantics together are not enough to decode the meaning of an utterance, because many utterances, many sentences are inherently ambiguous. Consider the sentence, "Someone stepped on his trunk," which has quite a different meaning depending on whether that pronoun refers to an elephant or a man with a suitcase. If I say to you, "Harvey saw a man eating fish," you don't know whether Harvey was in a restaurant or an aquarium. If you read that sentence in printed form, you'd know instantly what it meant because there'd either be a hyphen there or not. But hyphens don't show up in oral language. So just from the words and the syntax, you don't know what's going on. Utterance such as these can't be disambiguated by analysis of phonology, syntax, and semantics alone. We understand ambiguous sentences, and lots of the sentences we have to deal with are ambiguous, by making use of a fourth aspect of language, beyond phonology and syntax and semantics, known as pragmatics. Pragmatics really has to do with the context in which a linguistic utterance takes place. This context can be linguistic, in terms of other sentences that surround the ambiguous one and help clarify its meaning. Or it can be non-linguistic. The environmental context is important. If we're at a zoo and I say, "Someone stepped on his trunk," you're likely to look around for an elephant. If we're at an aquarium and I say, "Harvey saw a man eating fish," you're going to look around for a shark. Also important is prosody, or the pattern of emphasis given to various words in a sentence. Consider the following sentences. What am I doing here? 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 In each instance, the words are the same. The surface structure is the same, but the meanings are entirely different. The meanings are given by the way the words are spoken, not by the way they are strung together. Gesture, the way we move our hands when we speak, can also be important in helping the listener to clarify our meaning. And in fact, a very popular theory of the evolution of language says that spoken language began as gesture. The first language, way back when, may very well have been gestural rather than vocal, involving the hands and the face, perhaps with some grunts and cries to convey emotion. This proposal gains plausibility from studies revealing the communicative power of sign languages used in various deaf communities. But even among those with normal hearing, speech is accompanied by a tremendous amount of manual activity in the form of hand-waving and other gestures. This is true even when people speak over the telephone and can't even see each other's gestures. Language is connected to the hands, not just to the mouth. Setting aside the hands, our facial expressions and other aspects of body language convey a great deal about our intended meaning, and they can convey it even unintentionally. You can tell someone you love them, but if you're not smiling, if you're shuffling your feet, if you're not looking them in the eye when you say it, they'll never believe you. The importance of pragmatics in language is nicely illustrated by the question, could you pass the salt? Children who reply to this question with a yes get dirty looks from their parents and are immediately branded smart alecks by their teachers, because this is not a question about the listener's physical abilities. Rather, it's an indirect request to pass the salt. A sentence like this reminds us that language is not just a tool for individual thought, it's also a tool for interpersonal communication. Or, as the psychologist Herbert Clark has put it, language doesn't have so much to do with words and what they mean as it does with people and what they mean. From analyzing how sentences like this are understood, we learn that in order for the speaker and listener to communicate, they have to establish what Clark has called common ground, the knowledge, beliefs, and suppositions that speaker and listener share in common. Each must have some sense of what the other person knows, believes, and supposes to be true, and each must use this knowledge in structuring his or her communication. If the speaker and listener are not on common ground, they will not understand each other, and their interactions will not go very far. In order to achieve this mutual understanding, people have to manage their conversations, according to what the linguist Paul Grice has called the cooperative principle. Make your conversational contribution such as is required at the stage at which it occurs by the accepted purpose or direction of the talk exchange in which you are engaged. This principle, in turn, is unpacked in terms of 4 conversational maxims and some sub-maxims. First, the maxim of quantity. Make your contribution as informative as is required for current purposes, and do not make your contribution more informative than is required. Second, the maxim of quality. Try to make your contribution one that is true. Do not say what you believe to be false, and do not say that for which you lack adequate evidence. Third, the maxim of relevance, which is simply be relevant. And fourth, the maxim of manner. Be brief and orderly, avoiding obscurity and ambiguity of expression. Language is a powerful medium for communicating our thoughts to each other, for conveying thoughts from one mind, the speakers, to another, the listeners. And language is also a powerful tool for thinking. Many of our concepts are labeled by single words, and linguistic syntax allows us to combine familiar concepts in novel ways. Language is creative in that it allows us to think and express thoughts that have never been thought before. But some theorists have gone beyond this idea to argue that the language we use constrains the thoughts we can think about objects and events. The origin of this idea lies with Edward Sapir, a linguist who was a student of Franz Boas, himself generally regarded as the father of American anthropology, and also Benjamin Lee Whorf, a chemical engineer who took up an interest in language and studied with Sapir. In one of his papers, Boas had noted that the Eskimo language contained 4 quite different words for snow. Whorf and Sapir cited this example to suggest that these words encoded quite different concepts, and that if the language were lost, these concepts would be lost as well. In other words, the language we use constrains the kinds of thoughts we can have. The Sapir-Whorf hypothesis has a distinguished intellectual pedigree, but it's been controversial right from the start. The example of Eskimo words for snow has been particularly problematic. Over the years, the number of Eskimo snow words has been inflated to 50 or even 100. More important, Boas actually cited those 4 words to make another linguistic point entirely. And neither Sapir nor Whorf ever showed that Eskimos actually thought about snow any differently from, say, English-speaking cross-country and downhill skiers. Nevertheless, the Sapir-Whorf hypothesis has captured the attention of many social scientists. Its strong form is known as linguistic determinism, that basic cognitive processes differ depending on the language one uses. A weaker form says merely that there are parallels between the structure of a language and the way that speakers of that language think. Here's a famous example of the Sapir-Whorf hypothesis, studied by Lara Boroditsky and Alice Gaby. There's an Aboriginal group called the Pormpuraaw who live in the Cape York region in northeastern Australia and speak a language called Cook Thayor. These people have an unusual way of referring to direction. In English, we would use such terms as left and right, front and back. But in Cook Thayor, the Pormpuraaw refer to the cardinal directions of north, south, east, and west. Where an English speaker would say, "Put the fork to the left of the plate," the Pormpuraaw would say, "Put the fork to the west of the plate," but only if they were actually facing north. This feature of language obviously affects how the Pormpuraaw locate themselves and others in space, but it also affects their conception of time. English speakers, given a series of cartoon panels depicting a story, will typically arrange them in temporal sequence going from left to right, which is how we write. Hebrew is written from right to left, though, and Hebrew speakers will arrange the panels from right to left as well. But the Pormpuraaw arrange the panels from east to west, that is, from left to right if they happen to be facing south, but from right to left if they happen to be facing north. Apparently, how they speak about space affects how they think about time. Boroditsky and other proponents of the Sapir-Whorf hypothesis have collected many examples like this, and they conclude that Sapir and Whorf had it right. The diversity of environments in which humans live has created the diversity of language, and this diversity of language has in turn created diversity of thought. Each language provides its own cognitive toolkit and encapsulates knowledge and worldview developed over thousands of years within a culture. Each contains a way of perceiving, categorizing, and making meaning in the world. Still, there are lots of counterexamples. One famous set of studies focused on color terms. Cross-cultural research by Brent Berlin and Paul Kay had revealed a consistent pattern of color terms across the diversity of languages. If a language had only 2 color terms, they corresponded to black and white, or perhaps light and dark, or warm and cool. If it had 3 color terms, the third term was red. If it had a 4th term, it was either green or yellow. If it had a 5th term, it was the other one, yellow or green. Then blue was added, then brown, and so on. Eleanor Roche and David Oliver worked with the Dani, a tribe in New Guinea whose language has only 2 color terms, Mili for dark and cold colors, and Mola for light and warm colors. When asked to name color patches, the Dani obviously performed differently from English-speaking college students. But when asked to match color patches from memory, the Dani performed the same way the college students did, yielding highly similar color spaces. In other words, the Dani perceived and remembered colors the same way that English speakers did. Boroditsky and others continue to find examples where language seems to influence thought, but the first thing to be said is that thinking doesn't require language at all. Language makes thinking easier, perhaps, and more powerful, but there are lots of examples of thinking in animals who don't have anything like human language. Rats and pigeons form expectations concerning prediction and control during classical and instrumental conditioning. Pigeons have been found to form natural concepts. Rhesus monkeys are curious about their world. And Wolfgang Kohler, a German psychologist, found that apes could show insight in problem solving. For example, in order to obtain a banana that had been suspended out of reach, they figured out how to stack boxes on top of each other and then use a pole to knock down the fruit. And, for that matter, human infants engage in a great deal of learning and problem solving before they've acquired any language at all. The strong form of the Sapir-Whorf hypothesis, linguistic determinism, is certainly wrong. Thought isn't a mirror of language, but language is a mirror of thought. All human languages have certain basic principles in common, and these similarities outweigh any differences. And the weaker form, linguistic relativity, probably isn't quite right either. There are parallels between thought and language, but it could easily be that cultural patterns of thinking lead people to use language the way they do. What there is evidence for is what Daniel Slobin and others have called thinking for speaking. You can think any thought and express that thought in any language, but the structure of the language you use forces you to express your thoughts in a particular way. So you have to think about certain things before you speak, and what you say will nudge listeners toward a particular interpretation of what you mean. One example is grammatical gender. Many languages, though not English, classify nouns by grammatical gender, masculine or feminine, and sometimes neuter. If I want to talk to someone about my friend Pat, I can just refer to my friend Pat, leaving it ambiguous whether Pat is male or female. But if I want to express the same thought in Spanish, I have to say what Pat's gender is. Mi amigo Pat clearly communicates that Pat is a man. In German, meine Freunde Pat clearly communicates that she is a woman. I can't leave it ambiguous. The syntax of Spanish and German forces me to think about gender in a way that English does not. Here's another example. Different cultures have different kinship categories. I have 2 siblings, and in English I simply refer to them as my brother or my sister, or if I want to keep things ambiguous, I'll just refer to my siblings. But if I'm speaking Hopi, the language of a Native American tribe indigenous to the southwestern United States, I have to identify Jean as my older sister and Don as my older brother. But Don and Jean can use the same word to refer to me, their little brother. If I had a younger sister, they'd use different words to refer to her. If I want to talk about my friend Pat, I have to do so differently in Spanish than I would in English. But that doesn't necessarily mean that I have to think about Pat any differently. I only have to think about how I'm going to talk about Pat in Spanish. Any thought can be expressed in any language. Language doesn't constrain thought. As a powerful tool for thinking, language makes thinking easier. And it's an equally powerful tool for communication, providing us with a more powerful and flexible vehicle for communicating our ideas and experiences than any other animal has. Across cultures, languages are more alike than they are different, and so are human patterns of thinking.